Alright, today we're going to look at section 8.5. It is the final section in chapter 8. None of this is new. Basically, we're just taking all three methods that we've been practicing and we're mixing them up. So we're going to start each problem by discussing the method. So you're either going to factor by GCF, you're going to factor by dots, or you're going to factor by MA. Then you're going to use the zero product rule. I'm not telling you which way you're going to factor. You have to figure that out. So it's sort of a review of all the stuff we've done. They're just all mixed together. Here's that slide you've seen. This is probably the fourth time you've seen it. The problems that we're looking at today will be equations that are factorable on one side and equal to 0. So that's when you can use all these rules we're learning if one side is factorable and the other side is set equal to 0. So first we're going to factor using the multiple methods we've learned. Then we're going to use the zero product rule. Here is the first example. Go ahead and write this one down. Now, as you're writing, you should be thinking MA, GCF, or dots. And then kind of like, hey, there's no minus sign, so it can't be dots.
It has to be a minus sign or 2 dots.
Yeah, dots is a difference of two squares, so there has to be a minus sign. So if there's no minus sign, dots is out. Do they all have something in common? Then it might be GCF. If there are three terms, it might be MA. These are the things you should start thinking through. Anyone have an idea on this one? This one is MA. MA is when you have three terms. The first one is an x squared, followed by an x, followed by a regular old number. Remember, the regular old number in the back is your M. The number in the middle is your A. So we are looking for two numbers that multiply to 9 but add to 10. So we could do 1 and 9, 2 and 5. Do either of those add to 10? 1 and 9. So that's the numbers I'm going to use when I write my binomials. So this first step is just factoring by MA. Like I said, the only difference from last week and the week before is that I never told you it was MA. You had to come up with that part on your own. So the hardest part is figuring out how to factor and then remembering all the different factoring rules for the three methods. Once it's factored, we're going to use that zero product rule. So you can set x plus 1 equal to 0. You can set x plus 9 equal to 0 and then solve for your x. So minus 1, x equals negative 1. And minus 9, x equals negative 9. Once again, as you're writing, try to eliminate the different methods until you're left with the method that's going to work. Yeah, so Colin is noticing that each number is a perfect square. And there's a minus sign. So that is going to lead me to believe that we are looking at a dots problem. For dots, what number multiplied by itself will give you x squared? We have x and x. And then, yes, 9 and 9. One gets a plus, one gets a minus, and they equal 0. So x plus 9 equals 0. And x minus 9 equals 0. To solve that first equation, you're going to subtract 9 from each side. You get x equals negative 9. The next one, you add 9 to both sides, and x equals positive 9. So there are two terms. There's a minus sign, so you might be thinking dots, but is 6 or 18 a perfect square? Like, is there any number multiplied by itself that would give you 6? No. Doesn't work for 18 either. It's not going to be MA because there are not three terms. So what's the only option left? GCF. Very good. So you need to find the GCF between these two terms. We have 1 and 6, 2 and 3, x and x, 1 and 18, 2 and 9, 3 and 6 with an x. Yeah, I think we're looking at 6x as our GCF. So I'm going to divide each term by 6x. And I'm going to write a 6x in the front. 6 divided by 6 is 1. X squared divided by x is just x. So 1x, or x in the front. Minus 18 divided by 6 is 3. You had an x, but you're taking it out to the front, so just 3, no x. Equals 0. Now you can use the zero product rules. So what am I going to do? 6x equals 0. And x minus 3 equals 0. Everyone's getting this part up here kind of backwards. Remember, this is just 6 times x. How do you undo multiplying? Dividing. So you're dividing everything by 6. 0 divided by 6 is just 0. And then in the back we're going to add 3, so we get x equals 3. Questions? Alright, here's the next one. Number 4. Any idea how we're going to factor this? MA. What's my M? What's my A? Alright, so if I am multiplying to a 40 and adding to a negative 14, here are the numbers that are possible. What do I know about the signs? How do you multiply to a positive? How many negatives? How many? So a negative times a positive is a positive? Yeah, you need 2 negatives. If you're multiplying to a positive number, both numbers have to have the same sign. But if they're going to add to be a negative, that means that they both need to be negative. So go through on your factor list, or in your head if you're just using your factor sheet, and make everything negative. Now check to see if any of those give you negative 14 when you add them. The negative 4 and the negative 10. Good. So my binomials would be x minus 4 and x minus 10. Am I done with this problem? No. Now you use the zero product rule. So either this one equals 0 or this one equals 0. So what are my 2 solutions? So 4 and 10. Wonderful. Raise your hand if you have a question. Alright, number 5. Any ideas about factoring? Yes, this is a dot, so you can tell because there's a minus sign, and they're both what we call perfect squares, meaning there is a number multiplied by itself that can give you each of those terms. What number times itself gives you x squared? 2 times 2 gives you x squared? 2 is the back number. I'm with you on that. But how do you get the x squared part? X and x. Yep. One gets a plus, one gets a minus. Good. You had the right answer, just the wrong question. All right. Each one of these gets set equal to 0. And then you can solve for those x's. So I am coming up with -2 and +2. So what's my m?
20.
-20. Take care of those signs. The a is 8. So I'm going to list my ways to make a 20, then I'm going to figure out the signs. So these are the 3 ways to make a 20. If I want to multiply to a negative, but add to a positive, what do I know about the signs?
One negative.
One negative. Which one? Bigger or smaller? The smaller one. You want the bigger one to be positive.
It's gonna be 2 and 10.
So it is going to be -2, +10. So I'm going to do x minus 2, x plus 10 equals 0. Now you can go ahead and use the zero product rule. So x minus 2 equals 0 and x plus 10 equals 0. Add 2 to both sides. X equals 2. Subtract 10 from both sides. X equals -10. Raise your hand if you have a question. Alright, right again. It is MA. So what's the M?
14.
What's the A?
9.
-9. The ways to make a 14 are 2 and 14. No, 1 and 14, 2 and 7. If we want a positive 14, both sides need to be the same. They both need to be what? Negative. So go through and make them all negative, and then find the winner. Yes, -2, -7. So I'm going to do x minus 2. I'm going to do x minus 7. Quiet, only 2 more. We can do this. So x minus 2 is going to equal 0, or x minus 7 is going to equal 0. What do I do for that first one? Add 2, add 2. So x equals 2. And add 7, add 7. So x equals 7. Raise your hand if you have any questions. If not, we're going to jump right into number 8.
You'll jump right to number 8 so we can list to use for this. Yeah, just throw it on there.
Yes, this is a GCF. Does anyone know the GCF just by looking at it?
5.
5x.
X.
Yes, you can list the factors of 5x squared and 25x if you need to. If you can look at this and just know that it's 5x, go for it. So we have a 5x in the front. 5x squared divided by 5x just leaves you with the x. 25x divided by 5x just leaves you with a 5 equals 0. Now you can set each piece equal to 0, so 5x equals 0, or x plus 5 equals 0. So 0 is one of our solutions, and -5 is the other.
Done.
Raise your hand if you have any questions.